Good morning to all the students, the parents, and all the dignitaries present for the webinar today. This webinar series is being organized by Maharashtra Education Society to commemorate the post-centennial Diamond Jubilee celebration. This webinar series is focusing on various career opportunities available for students after 12th standard. Today, before I start with today's webinar, I would like to welcome all the dignitaries from Maharashtra Education Society. First and foremost, I would like to welcome Rajiv Sahasrabudhe, Chairperson, Governing Council, Maharashtra Education Society. I would also like to welcome both the Vice Chairmen of Governing Council, Maharashtra Education Society, Dr. Madhav Bhattji and CA Abhay Shirsagar sir to this webinar today. I would also like to extend my warm welcome to Dr. Bharat Vankate, Secretary, Maharashtra Education Society. I would also like to extend my welcome wishes to Professor Sudhir Gade sir, who happens to be Vice Secretary, Maharashtra Education Society. I would also welcome all of you on behalf of Maharashtra Times, the media partner for this webinar series. Today, being the sixth day of this webinar, we are focusing on career options present in engineering field. Today, the world is full of examples where technology is empowering humankind. It's worth mentioning that the engineer's mind is the mind who works to get this cutting edge technology to help humans. It is also the engineer who works to transform the in technology in empowering humans and also to helping the world wide. Thus, millions of youth every year come to become a successful engineer and come to perceive this promising career. Thus, today, to share about this career opportunity, we have a very eminent speaker, Dr. Manisha Yogesh Khadalkar from COEP Pune. Dr. Manisha happens to be Associate Professor of Chemistry. She has a vast experience of 20 years in teaching. She also has an experience of 25 years in research work. She's also acted as head of Applied Science Department for last 14 years. Her educational qualifications are BSc, MSc Analytical Chemistry and PhD from University of Pune in Chemistry. She is a faculty coordinator at Student Satellite Project CSAT and she is also a coordinator for FY BTech and academic coordinator for Triple IIT Pune. She is also a faculty coordinator at Astronomy Club. She is also a member at Deccan Gymkhana Working Committee. She is also the recipient of CEDA Innovative Teacher Award 2016. She is also a proud recipient of GYTI Award for Mentor Frugal Innovation Swayam. She has also bagged the PMC Best Teacher Award by DRDO in March 19. She has also delivered TEDx talk on Swayam, a success story of teamwork at NIT Raipur on 25th March 2017. She has a good research experience in working in the field of material science since September 1992. She has a number of publications, 19 papers in international journal, 1 in national journal, 8 papers presented in national conference, 5 papers presented in national and international symposiums. She has a rich library of ongoing research projects She has completed many research projects funded by ISRO and University of Pune in stipulated time. The total research grant that has been received is very close to 80 lakhs. That is a big amount. She is also a research guide and a supervisor for MPhil and PhD work. She is presently supervising PhD work of 3 students, and one of her students has already completed PhD in chemistry from University of Pune. She has been organizing many conferences. To note some, national conferences we met in September 2010 was being organized, and National Conference on Material for Electronic Appliances was being organized on January 2014. She has also chaired the session at Bioengineering Sciences National Conference 2013, and she is also a secretary with Sharada Shakti, a national movement for women, NGO working for spread of science and technology among women and children since 2020. I welcome you, ma'am, and we are really proud to have such an eminent speaker today to enlighten and guide our students for various career options available in engineering field. Over to you, ma'am.
Thank you. I take this opportunity to thank Maharashtra Education Society and Maharashtra Times for giving me opportunity to interact with potential engineering students of coming year. Uh, Without much ado, I think we would like to start the presentation on different career opportunities in engineering. So let's begin. An overview of degree course in engineering. For most of the science students, the most preferred option is engineering. And why is that? Parents' wish, peer pressure. Right after graduation, one can start earning. So you are ready for market in 4 years. These are the most lucrative career options with high social status. But these are, I think, all wrong reasons to join engineering course. Why one should join? Many specializations and multiple options. We are just going to see most of the popular specializations in engineering. And one should have passion for engineering, problem solving, creativity, and interest in hands-on work. Who controls engineering education in India? It is AICTE, All India Council for Technical Education. And top engineering institutes in India, Maharashtra and Pune. See, in this particular sequence there are 23 IITs. We are all familiar with about 5, but since 2000 there are many new additions, and entrance exam required for IIT admissions is JEE Advance. Total number of seats in all 23 IITs are 11,273. These are all current this year figures. After that, there are new 25 triple ITs. Triple ITs are Indian Institute of Information Technology, and mostly electrical group branches are available at triple ITs. The total student intake is 3,433. Next, there are 31 NITs, and with a total intake of 17,868. Then we come to government funded engineering institutes. All over India, we have 23 such institutes. For triple ITs, NITs, and government funded engineering institutes, JEE mains score is valid or is considered, and you'll see that the total number of seats in triple ITs, NITs, and GFIs is close to about 26,000. Then these are all tier 1 institutes, very eminent institutes of engineering where students from all over India are competing. Then we come to next layer of institutes, which is private engineering colleges, which are of very high significance and high repute, like BITS Pilani, Manipal, SRM, to name a few. There are 50 such private engineering institutes, and the total intake is about 25,000. The number is very big. Each institute or small group of institutes have their own entrance exams, and all these entrance exams are conducted after 12th board exams are completed. Then come to Maharashtra level, state level. There are 9 government engineering colleges and COEP is one of them. There are 4 government funded institutions, technical institutions like ICT, Bombay, like Walchand. So like that there are 4, and the total intake of these 9 plus 4, 13 institutes is 3,665. In our Pune itself, there are 115 total engineering colleges with a total intake of more than 30,000. So we can say that there are plentiful opportunities for engineering at India level, at Maharashtra level, and Pune level. So I'll say that students and their parents should take stock of all these things, decide your own potential, and then depending upon that you should go for a particular institute or set of institutions as your target institutions. Now, in though you go to any tier 1 or tier 2 institute for engineering course, what are commonalities? 12 very significant attributes which are expected from engineering graduate are engineering knowledge, problem investigation, problem analysis, designing and development of solution, use of modern tools, software tools as well, and for whom all these engineers are working. They are working for betterment of society. So the aim is to develop engineers who will work for society. While working, he should take utmost care of environment and go for sustainable development. These are the keywords these days. You should practice engineering with ethics, have an individual contribution as well as contribution as a team, for which you should be able to lifelong learn newer and newer technologies, have very effective communication and knowledge of project management and finance. So an engineer is not a complete engineer with knowledge of the core subjects, but he must be industry ready. And every engineering course, we will see course structure next. From where this course structure has arrived, it is from these requirements or graduate attributes. Now, over 4 years, you will be earning credits of the order of 160 to 177 from different type of courses which are separated into different categories like humanities, social sciences, and management courses. And the total credits, this is as per AICTE guidelines. So, AICTE guidelines are to be followed by all private, public, tier 1, tier 2 type of institutions equally. So, wherever you go for engineering, the structure will be very close to this structure. Then there are basic science courses. Mathematics, physics, chemistry are termed as basic science courses with total credits 25. Then comes your engineering science courses. They are primarily courses which will give you skills to work with your own hands. There is workshop where you learn about mechanical workings. Then learn drawing. Earlier it was all pen and paper. Now you have computer aided drawing also. Basics of electrical, mechanical, computer, and this all thing comes in first 2 semesters, foundation year, first year. The total credits for this hands-on experience are 24. Now we come to professional core courses. Uh, Nowadays, the race is either I should get computer or I should get mechanical. These are two major groups of interests. Now, whenever I say I'm a mechanical engineer, I take 48 credit equivalent courses in mechanical engineering. But that's not all. There are cross-functional requirements. And for that, interdisciplinary courses are also required, which come in the form of professional elective courses relevant to chosen specialization, which are worth 18 credits. Open electives, which are again from different or same branch, which are worth 18 credits. And in final year, you have a major project work. In second and third year, especially in fourth and sixth semester, you will have some smaller projects and seminars to give. Nowadays, new introduction is internship, and it is expected that a student will do a minimum of 10 weeks internship right from first year till the final. Then your social responsibility, environment, sustainability, values, these are called as mandatory learning courses. Mandatory learning courses are compulsory across all tier institutes. They are audit courses, means you need to pass, learn, give exam and pass these courses, but there are no formal credits, but they are equally important in your overall development as an engineer. This over 4 years or 8 semesters, you will collect 160 credits to 170 credits. There is a little flexibility given to individual institute, but there will not be less than 160 or more than 180. So this is the general condition. Now we'll see what are inclusions and requirements of an engineering course and who is an engineer. Engineering is application of physical sciences, mathematics, technology, art and practical experience. To do what? To do design, produce, maintain, and improvise. What? Objects, tools, and machines. And professional practitioners of all the above are called as engineers. Now, what to build, what to design, and what to maintain. This gives rise to different branches of engineering. So, first set we'll start with infrastructure development. We need development of roads, railroads, buildings, bridges, and many more things. This primarily comes into domain of civil engineering. Next, agricultural equipment, tractors, tools, thrashers, cutters, water lifting pumps. These are all now modern tools required for organized agriculture. Develop vehicles from aircrafts, spacecrafts, trains, ships to different type of automobiles, four-wheelers, two-wheelers, and so on. Develop machines, computers, electronic appliances, engines, develop environmental systems, medical devices, small electronic components like sensors, transducers, and so on, and carry out research of on better fuels, more efficient fuels, carry out research in the field of nanomaterials and different type of systems. So, design what? Infrastructure. Build what? Machines. And whenever something is built during its lifespan, sometimes it will require maintenance. Sometimes if it fails, you will have to change some parts, accessories, and restart it. So everything comes under the scope of engineering. Engineers apply. How do we do this? Apply sciences using hands-on experience and improve efficiency of working system as if and if troubleshooting is required in case of a failure, do that. The work of engineer forms link between scientific discovery and the application that meets needs of the society. So we have seen earlier that an engineer should work for society, and usually discoveries in pure sciences should not remain restricted to laboratories. They should develop applications which are useful for you and me, right? So this is the scope and spread. Now let's see major branches of engineering. I have arranged these branches not in exactly chronological sequence or sequence of importance, but I have grouped them into different sets. For example, civil engineering, which develops infrastructure, is the oldest set of branches of engineering, which includes civil, construction, water management, environmental engineering, and even marine engineering. Next comes electrical group, and this group is the vast and most significant group in today's context. Electrical engineers do what? Generate electricity, distribute electricity to you and me, and during circulation, if there are any transmission losses and all, they try to reduce them. At the same time, a small group works on electronics and telecommunication. This is an era of fast communication. And who helps it? Electronics and telecommunication. Instrumentation and control. It is not only instrumentation, but instrumentation to control different industrial processes. Next, and your most favorite group is computer. Information technology is an offshoot of computer, and computer science or computer engineering or computer technology is looked upon at two different levels. One, build a computer, which is in the purview of hardware development. And next is the use of computer, and using computer, how to do faster computing, which is done through software development. Computer or even information technology has now become a run of a mill branch. But what is new in this? Data science, artificial intelligence, machine learning, big data, and everything finally finds application in space technology. So I have grouped them together. Next, we come to all muscle power, mechanical engineering group. Develop engines, run engines, find troubleshooting, using engines in layer 2, produce something which falls in the purview of production engineering. If you are specializing into metal work using metals, alloys, ceramics, composites, intermetallics, then it is called as metallurgy and material science. Automobile, aerospace are two important offshoots of the group of mechanical engineering. Next, come to chemical engineering. Now, here, knowledge of material science, chemicals is put together to generate, produce different applications which are FMCG, consumer goods. And for you and me, this branch is indispensable as all the products we need to use in our daily life. What are allied branches? Polymer, plastics, petrochemicals, paint, textiles, and many more. When you think of entering into engineering, first thing a student thinks after 10th is to leave biology aside. But you will see that biology also plays a significant role in engineering with a branch biomedical engineering, biotechnology, instrumentation or biomedical instrumentation in particular, and tissue engineering. So this is a highly specialized use of hybrid between engineering and biology. So this is a rough classification of different branches of engineering. Now, one by one, we will go to see specific applications of a branch to a specific application area. Here you can see a worker, engineer doing survey work. You can see some bridges, some structures, and all this falls in purview of civil engineering. After doing civil engineering or after becoming a civil engineer, where do where to look for opportunities in government sector? PWD or Public Works Department, which actually develops roads, railroads, bridges, and all these structures for civilizations. CPWD is Central Public Works Department, Railways, even State Electricity Board, and in defense, military engineering services. In private sector, infrastructure companies which build housing complexes, bridges, dams, roads, interior designing, and landscaping. So there are plentiful of opportunities in civil engineering, and their role is very important. Next is, as civil engineering is a conventional engineering branch, next conventional engineering branch is electrical engineering. What you can see is transmission line support towers which take electricity from a power station to an individual household. Illumination, space illumination through electrical circuitry. Career opportunities in electrical engineering, again PWD, CPWD, railways, state electricity board, military engineering services, individual house building complexes, and in private sector prepare various electrical equipments like transformers, build substations, electrical components, appliances, work at electrical power stations. Electricity in India is conventionally produced by thermal power station and hydroelectric power station. But nowadays, there are some nuclear power stations, solar photovoltaics, and other non-conventional energy sources also like wind, tides, which generate not very significant percentage wise but locally significant electrical sources. An allied branch of electrical engineering is electronics. Now, electrical engineer works on a mega scale, whereas an electronic engineer works on a small scale. Diode, transistor, IC chip, VLSI design, and now there are multi-layered PCBs which are built and used by electronics engineers. Where to find jobs? Railways, state electricity boards, in defense production systems, especially radar, sonar, signaling system, and instrumentation. Software industry, private sectors which are manufacturing scientific instruments, entertainment, electronic products, build computers, make picture tubes, medical equipment, and there are many more applications of electronics engineering. This is a PCB. On this PCB, you'll see multiple different type of components, smaller components built, and this is a small equipment in itself. Now come to your most favorite branch of engineering, computer engineering. It integrates several fields of electrical engineering and computer science required to develop computing systems. Computer engineers usually have a training in electronics, software design, hardware, software development, hardware, software integration, instead of only software engineering or only electronics engineering. So you can see that it is a applied branch where you are utilizing primary knowledge of electrical and electronics engineering and software development and put this knowledge together in integrated way. Career opportunities, of course, plentiful, and most of them are in private sectors. What are the emerging areas? Artificial intelligence. Now, so many smart applications are arising practically daily of artificial intelligence. AR, augmented reality and virtual reality, big data, machine learning, deep learning, these are all buzzwords. If you go to any campus interview in your third year, mostly All questions are directed on these fields. If you say, I know I have done some work in these areas, then your chances of getting picked are really high. Next important branch in the group of electrical is instrumentation and control. There is process instrumentation, there is biomedical instrumentation. So, build an instrument or use it for automation. This is very important. Principle and operation of measuring instruments for automated systems in electrical and pneumatic, both the domains. Industries with automated processes at chemical and other manufacturing plants with goal of what improving system, increasing efficiency, improved productivity, reliability, safe working environment, optimization of the output and stability of the system as such. So it is a very significant work so that mass production in batches goes on without any tension. Career opportunities again in public and private sectors. Manufacturers of chemicals, fertilizers where process control, automation, robotics is required, medical equipment. Now, whenever you have a broken bone or you are having analytical requirements, we turn to biomedical instruments like X-ray machines, like simple blood glucose or plasma level, hemogram, sonography, or sophisticated instruments like MRI instruments. So, all they are controlled, manufactured by instrumentation engineers. Now, come to mechanical engineering group. Make machines, run machines, improve efficiency, improve fuel economy for automobiles is their prime motto. Carry out air conditioning, run air conditioning effectively with lesser and lesser electricity consumption is their motto. Apply principles of physics, material science for analysis, design, manufacturing, maintenance of mechanical systems. This involves production, usage of heat and mechanical power for designing, producing, operating machines, tools. It is one of the oldest engineering disciplines. Allied branches, production. Whenever I make different machines, where do I use them? I use them for production. So it comes in the domain of production engineering. Again, it's an allied branch. You produce something in smoothest fashion, most judicial and economic way, and with maximum speed. This requires a combined knowledge of mechanical engineering as well as management. So I said it's a hybrid or allied branch between management science and mechanical engineering. Production engineering is a combination of manufacturing technology with management science. A production engineer typically has wide knowledge of engineering practices and he is aware of management challenges related to production. Career opportunities in government as well as private sector, automobile, shipbuilding, auto components, accessories, engineering goods, tools, compressors, different fabrications, welding, forging, in aviation industry, in consumer products or domestic appliances. So the range where production engineers are required or employed is really very wide. And that's why a good production engineering course requires actual engineering, actual industry experience. And that's why production sandwich course incorporates about 1 year training in actual working at an industry in sixth semester and seventh semester. That means second semester of third year engineering and first semester of final year engineering. For complete 1 year, engineers work in industry. Students work in industry and take the feel of how is an engineer's life before becoming a full-fledged engineer. Now come to metallurgy and material science. Most abundant elements in periodic table are metals, and for all structural strength materials which are used are metals and their alloys. So metallurgy and material science encompasses use of metals, make alloys out of them, make intermetallics, make ceramics, make composites of different type and use them for mechanical and production type of application. It is a technology of metal where sciences are applied to their actual industrial practice. You will see that in Maharashtra, we have very few places or very few institutes where metallurgy and material science is offered as a branch, primarily because it requires a lot of material, a lot of capital investment for this course and lot of advanced sophisticated instruments like XRD, SEM, TEM, UTM type of machines are required for metallurgical analysis. And that's why we see that this branch is offered only at selected institutions. Career opportunities in metallurgical engineering. Again, government sector, defense sector, they use all heavy machinery, castings. They are made on large scale at government sector and defense sector as well as in private industry, automobile, shipbuilding, auto components, accessories, engineering goods, fabrication, welding, forging. These are primary operations which are seen in a metallurgical industry, aviation industry, and so on. Now we come to a group of chemical engineering. Now, why I say that it's a group of industries or group of branches where chemicals are used as raw materials to produce consumer goods. And here, knowledge of physical sciences, chemistry is integrated with engineering to produce consumer goods. Chemical engineering is a branch of engineering that deals with application of physical sciences and life sciences. It is combined with mathematics and economics because finally, for an industry to become profitable, this economics plays a very significant or key role. Convert raw materials or chemicals into most useful or valuable consumer goods. Pioneering value new materials, new technologies like nanomaterials, nanoceramics, nanotechnology, fuel cell technology, and biomedical engineering are offshoots of chemical engineering. Polymer engineering, polymers are or artificial polymers are relatively very new class of materials. If you see metal, ceramics, glasses, they have been there for thousands of years, and people have been using these for many years for building structures or producing different applications. But polymers, which are synthetic polymers, synthetically manufactured polymers, have a history of not more than 100 to 125 years. But the materials have become so significant that polymers have displaced all other conventional materials from their conventional applications. For example, if you see old Ford cars, the entire body was made up of steel. The aircraft structures were primarily used using aluminium and magnesium alloys, whereas nowadays car bodies are mostly made up of polymers, composites, or metal polymer composites, carbon fibers for lightweight. All these new inventions fall in the domain of polymer engineering. Polymer engineering is generally engineering fields which deal with design, analysis, modification of polymeric materials. If you see a polymer material by itself, it doesn't have any strength, it is not very high density material, but still when it is compounded, specific word, compounded, added with materials from different other classes, it becomes equivalent or even better than almost all conventional materials. Polymer engineering covers aspects of petrochemical engineering because for all polymers, raw material comes from petrochemicals. Polymerization process because raw materials are converted into a polymer by a process of polymerization. Whenever a polymer is being formed, its structure plays a key role in deciding its properties, and naturally, based on these properties, its applications are significant. Therefore, to make polymer, to test its properties, and based on its structure, different applications are developed. All this falls in the domain of polymer engineering. What you can see right now in the picture are different products which are coming from different type of polymer engineering. Simple things like dustbins, buckets, milk crates, CDs, DVDs, all type of food grade containers at home, to lightweight carbon fiber used in ships, hovercrafts, racing cycles, to small components used in aviation industry. The spread of use of polymers and plastic is very, very vast. Career opportunities, private sector companies producing various products in large scale as well as small scale. Automobile companies, companies where irrigation, oil, gas, cable are produced and distributed. See, all this irrigation, oil, gas, and cables are running underground, and they are running through pipes. These pipes come from polymers. production units of various polymers. The career opportunities in private sector for polymers and plastic production are really unlimited. Next, allied field of chemical engineering is paint technology. Any metallic surface or even non-metallic surface looks more aesthetic, or even households look beautiful if they are coated with paints. And these paints are also different type of chemicals. Paint technology application is a combination of processes using metallic and non-metallic surfaces are chemically treated, then a coat of paint is applied for purpose of protection from corrosion, especially in case of metallic structures, and for decoration in both metals and non-metals. In the discipline of paint technology, one studies about manufacturing of paints, use of various type of paints, and techniques of application of paints to different surfaces. It requires some bonding between the substrate and the paint. So a primer is required when your household walls are to be painted. Career opportunities in paint, naturally, paint manufacturing companies, and not only paints but lacquers, varnishes, lubricants used in large scale and small scale require knowledge of paint. Industrial paint work, automobiles, and other engineering. Small scale painting works like spray painting, automobile, bungalow paintings, and building paintings. We all look good and like to use different type of clothier, not only for ourselves but ranging from fishing nets, cord clothier, nylons for application in parachute strings. Textile engineering encompasses it all. Chemical engineering principles implemented for processing and production of all kinds of textile, fabric, yarn from textile fibers. So, manufacturing of fiber, making fabric out of it, and painting or dyeing that fabric, everything falls under the scope of textile engineering. The discipline involves extensive study of chemical and physical principles, which are utilized for detailed study and analysis of behavior of polymers, behaviors of fibers, behaviors of blended fibers where polymers and natural fibers are blended together. Everything is involved in textile engineering. Now come to a very elite branch, that is biotechnology. Applied biology involving use of living organisms, bioprocesses in engineering, technology, and medicine. This is the scope. Biotechnology does what? It utilizes the product for manufacturing purpose. The concept encompasses produces for modifying living organisms according to human requirements. It may be as simple as modifying the crop patterns, generations of biologically modified seeds, or hybrid breeding of animals, cultivations of specific plants, having special breeding programs to select hybridization. Now, this is a branch where nature is manipulated for the use of society. And a word of caution, it better remains for the benefit of society only without causing harm to nature. This is very, very essential. Now, with this, I would like to take up if there are some questions. For all students, happy learning and all the best for preparations. I'll say that it is easiest to get admission into engineering college, and it is even easy to find your branch of interest at some place. But you have to be very selective in choosing your stream based on your liking, based on your abilities, and take stock of things, have a systematic plan, have focused efforts so that you can go to your choice of institutes. Thank you. Now, if there are any questions, if there are any accumulated questions, I would like to take those questions. Thank you. Hello.
Hello, ma'am. Am I audible?
Yes.
Thank you so much, Manisha madam, for such an enlightened lecture. I'm sure that students must have been guided really well, and they now know what many streams are there in engineering, what to select, how to go ahead. That was really great. Madam, we just definitely have few questions, and
Okay.
I would just read out few of them, and
Okay.
then we would just proceed further. If you could answer them. So
Hmm.
the first question says, Madam, I want to know about the career in product and automobile design. Do you recommend mechanical engineering and then study for design, or can we study graduation in design and design can still get through the opportunity?
Very good question, and I'll be able to answer this question at length. Uh, few years back, there were very few design institutions, but yes, nowadays there are many design institutes relatively, though the total intake is very limited as compared to engineering. But yes, if you are really focused on learning design and especially automobile and transportation design, then you should take up 4 years B design course. This 4 years B design course is offered at UID Gandhinagar, especially in automobile design. Otherwise, there are plentiful of institutes which offer this course, and at MIT Urali Kanchan, MIT ADT, they are also offering this course in automobile and transportation design. But rather than going into mechanical engineering, if you are focused on designing, then I would recommend that you take 4 years B design course itself rather than engineering. Alternatively, what you can do is 4 years mechanical engineering followed by 2 years masters in transportation design. This is also available option.
Yes. There is a question that says that is there any difference between BE and BTech?
Practically, in if institute is affiliated to different universities, still These universities are offering BE degree, whereas uh, autonomous colleges, IITs, triple ITs, NITs, and IITs, they offer degree of BTech. But structure wise, there is very little difference in BE and BTech.
Question. Ma'am, there is another question which says,
Yes.
what is the scope in biotechnology?
Uh, just now in my presentation, I showed you that under biotechnology, you can go in 3, 4 different forms: alcohol manufacturing, fermentation technology, or conversion of natural products into medicines, or modification of tissues for modification in different varieties of crops, cultivation, breeding programs. These are the areas where biotechnology finds applications.
Madam, there is the last question again. This question
Okay.
says, can you please tell us the scope, career opportunities, and colleges in Mumbai and Maharashtra for the admission to food technology, BTech in food technology?
Uh, I'm not completely aware, but uh, this also comes under this food technology, or hotel comes under management and catering technology. It is again under AICTE only, like engineering courses. In Maharashtra, there are 5 government institutes which are HMCT, Hotel Management and Catering Technology, but especially food technology or food processing, I'm not especially aware of. If specifically fats, oils, soaps, detergents, or petrochemicals, this is your area of interest, then these courses are offered by ICT Mumbai.
Ma'am, there is one more question that has popped up right now. It says that, is it okay if I don't take biology in 11th and 12th and I want to become an environmentalistic or geological engineer?
Technically, it is possible, but if you are really inclined to become geological or environmental engineer, which is still under the purview of civil engineering, it does not require biology as a mandatory condition. But having biology as one of the subjects is always an advantage if you want to continue in environment or geology. Recommended, but not mandatory.
Ma'am, shall we go on for one more question? I mean, there are so many.
Fine, I am ready.
Ma'am, what is the difference between computer science and computer engineering?
Computer science is basically about software development. There is little aspect of hardware in it. If it is integrated, then we come into the domain of computer engineering.
Ma'am, the last one to go again. Uh,
Okay.
Ma'am, I have a question. Is software engineering a good field for making career or it changes according to time?
Actually, if you look at it today, I'll say that it is the most looked after, most coveted branch of engineering, and at least for a foreseeable future, it will remain a leading branch. So, yes, it makes sense to have a career in software engineering.
Thank you so much,
But
ma'am.
you will require a lot of marks for that in a good institute.
Yes, ma'am. Yes. Yes. Thank you so much, ma'am. This was definitely an enlightened session. I'm sure the students have benefited through this and they now know what are the options available in engineering, which to pick, which not to choose, what to see ahead. Thank you so much for your guidance. I would also like to take the opportunity to thank all the dignitaries of Maharashtra Education Society for making this webinar available for students so that they can have a feel of different careers. I also thank Maharashtra Times for being our media partners to present this webinar to the students. I would like to thank students and parents and the members present over here who are helping in webinar and the audiences also who are going through this. And just a small reminder, tomorrow we have a webinar on different career aspects in journalism and mass communication. Please do not forget to log in and watch that also. Thank you so much.